So just keep that in mind. So now we can start graphing it. So draw your set of axes. Where's our points? So that's at -1 here and about -5 somewhere over here. Connecting the dots, and we've got a local minimum from that. So we're going to have a -3 about there, down 4, so about there. And then just connecting the dots. Again, it looks like very similar to a quadratic. It is hard to draw sometimes, but it's meant to be a little bit flatter, I guess. So there's our points, and we've got 0 and 65 over 4 as our y-intercept there. Okay, so that's sketching the first quartic. And we might as well have a look at the next example. So this one is looking at y equals minus 3x, take 1 to the 4, take 7. Okay, this time we've got a 3 in front of the x. That causes problems because we need something that looks like a x take h cubed, sorry, onto 4 now, take k, plus k. So we want x by itself. So to start with, I need to take the 3 out. So if I take that 3 out, I'm going to be left with an x here. Now, -1 times what gives me, sorry, 3 times what gives me -1, and that's going to be 1/3. Okay, now I have something that is x take something, okay, and I just need to get this 3 outside of this power of 4. So what I can actually say is minus, okay, I can say 3 to the 4, and that's times by x take 1/3 to the 4 using our indice laws. So we'll have 3 to the 4, which is -81, times x take 1/3 to the 4, take 7. Okay, now I have something that looks like this. That 3, as I said, causes problems, so I need to take that out. It does cause problems trying to find this number here, but just think of, what do I need to multiply 3 by to get -1? And that's just itself, or the reciprocal of it. So now I can start solving for like before. So we have our turning point at, this will be +3rd minus a 7. Okay, and we have a is less than 0 this time, so we have a local maximum point. And our y-intercept, again, is going to be simpler than finding x's, even though we have to do both. Yeah, that's the equation I'm looking at. We'll have y equals -81, 0 take 1/3 to the 4, take 7, 1/3 to the 4, so it'll be 3 to the 4, so it should be -81 times 1/81. Take 7, so that'll be +1 take 7, should give us -6. And just checking that. Oh, that's why. That should be a positive there. Negative to the 4 makes a positive, so it should actually be -8 for our y-intercept. Now, for the x-intercepts, and we have 0 equals -81, x take a third, to the 4 take 7. So bring the 7 across, then divide by 81. So 7 over 81. I'll make it negative. X take a third to the 4. Now, taking the fourth root of both, so the fourth root of -7 causes problems. Why does it cause problems? Well, 4 numbers that multiply together to get -7, and you can't get a negative number. So that indicates that we have no solutions. And if there's no solutions, it means there's no x-intercepts. So, if there's no x-intercepts, it means it doesn't cross the x-axis, obviously. But we also know that we have a maximum point, or turning point. Maximum turning point. So, when we graph it, we know our maximum turning point is at positive a third. So, I'll say somewhere over here. And down 7, so over here. And we know that's a maximum. And because it doesn't cross the x-axis, well, it's just going to look something that looks like this. And this is a third and -7. We also know our y-coordinate is at -8, and that's all we have to do. Okay, so if you get no solutions for x-intercepts, that's okay, don't panic. It just means it doesn't cross it. And although that might be strange at first, once you kind of look at the previous information, it might make a bit more sense. So, local maximum turning point, and the y-intercept's going to be a little bit below that.